Hello YouTube, welcome back to my channel. So in today's tutorial we're going to go over our binary search in implementation using Python, C++, and Java. Okay, so let's get started. First let's get out to know what binary search is all about. So let's see how binary search works. So binary search works on only sorted array. Okay, so your array or list, whatever you call it, must be sorted in order for you to perform a binary search. Okay, so in this example you can see that I have a sorted array, right? So 2 4 6 7 8 10 13, and then you can see all of the values are in sorted order. So let's say that I want to search for a value called 6, and 6 is the value that I want to search for and get back its index. So how binary search works is that we have the left pointer and then the right pointer. So the pointers are the arrows that are represented by the red. Okay, and then you also have something known as the middle value, and the middle value is what is represented here by blue arrow. Okay, so we are going to have a left value which is going to be an index, an integer, and then the right value is going to be an index, an integer, and then you're going to have the midpoint, and the midpoint is just the left plus right divided by 2. You take the integer division of that sum. Okay, so for example I have this array here, so its size is just 0. Its size is just the left element is at index 0, so this is 0, and then the right to be at 0 1 2 3 4 5 6 7 and 8, right? So now we need to find the midpoint, and the midpoint is just the sum of the left plus the right, and then you find its integer division, which is just going to be 0, which is the left, plus the right, which is just the right index, which is just 8. And if you divide that, you get an 8, right? 0 plus 8 is just 8. And then you define the integer division of that, that's just 4. So the midpoint to be at index 4, so this is 0 1 2 3 4. So at index 4, that's where our midpoint is. So what we're going to do now, we're going to compare the value at the midpoint with our target value. We're going to check if the midpoint is equals to our target value. Okay, so we're going to check compares 9 and 6. In this case, 9 is not equals to 6, so we're not going to return the index as being the index of 6 as being the mid value. So now we need to check, is 9 greater or equals, is 9 greater or less than 6? In this case, 9 is greater than 6. Since this array is sorted, then 6 must be somewhere in the left part of the array, because all of values from 9 to the right are greater than 6. So the value 6 must be somewhere on the left, right? So that's how we need to now we need to adjust our array. Now we can see that all the values from 9 upwards, right? 6 is obviously not there since this array is sorted, right? So I mark them as green, meaning that we will not be concerned about them. So now that we have marked this array as green, so our focus now is just going to be this part of the array. So this subsection is what our focus is. So now we need to calculate the left index and the right index for this subsection of our array, this sub array. Okay, so the left. So now that we know that this is not in this part of our array, meaning that we need to move our left pointer, our right pointer, we need to readjust our right pointer. So our right pointer, we need to readjust it to its index to be the mid minus 1. So if the index of the mid is 4, then the midpoint should be 4 minus 1, which is going to be 3. So we're going to move this left index to this position right here, and it's going to be at index 3. You can check this is 0 1 2 and 3. So right now we have that sub array which is marked by this left index and the right index. So now that we have that, we need to calculate the midpoint, which is just going to be 0 plus 0 1 2 3. So it's going to be 0 plus 3, and then we find that it's integer division. So 0 plus 3 divided by 2, that's just 1.5. and then if you find that it's integer division, that's just going to be 1. So our midpoint is going to be 1. Okay, so now our midpoint is at 1 and points at 4. So we're going to check again, is 4 equals to 6? This is not the case. We'll check, is 4 greater than 6? This is not the case, meaning that the value that you're looking for, 6, is probably on the right side of our array, right? So now we'll mark 2 as not a part of our concern. So our concern is just about from this part of the array until this part of the array, right? That's our concern. Rather this part of the array to this part of the array, right? I made a mistake, I didn't shade this to be green. So it's going to be the current index of the mid, which is just going to be 1 minus 1 plus 1, right? So I'm going to take this value plus 1, so the index of the midpoint plus 1, which is just going to be 1 plus 1 is going to be 2. So we're going to move our midpoint, our left pointer to be midpoint plus 1, which is just going to be here, right? We're going to move it here, and then so now our focus is just going to be 6 and 7, right? So now we need to calculate the midpoint. So the value for the index for 6 is just 0 1 2, right? So 2, and then the value for the index for 7 is just going to be 6. So 2 plus 2, sorry, is going to be this is 0 1 2, right? So this is going to be 3. So 2 plus 3 is going to be 5. And then if you find the division of 5 divided by 2 is just 2.5. Its interior division is just going to be 2. So our array, our value, our midpoint is going to be at 6, right? So we move our midpoint to be 6, and also our left node, our left pointer is also at 6. So now we check at 6, which is our midpoint. We check if the value at midpoint is equals to our target value that you're looking for. So 6 is 6 equals to 6. In this case, that's the truth, right? 6 is equals to 6. So we have found our value, and we're simply going to return the index of 0 1 2. We're going to return the index 2. That's where our value, our 6, is found. So we're going to continue this process as long as the left is less or equals to less or equals to the right pointer. So as long as the left pointer is less or equals to the right pointer, we're going to repeat the process that I have just explained to you. Okay, we're going to be dividing, finding the midpoint, and then adjusting the left and the right pointers, adjusting the mid values afterwards, comparing, and then making the adjustments all over again. We'll continue to do that in a loop that will continue when the left is less or equals to the left pointer is left or equals to the right pointer. Okay, great. So I have this the GIF image right here. So you can see we're trying to look for, our target is 47, so our mid was 28. So we know that 41 is on the left side of 28, so we took only this sub array, and then we calculated this mid, which is midpoint is here. When we got 67 is greater than 41, so we know that the value that you're looking for is on the left side of our array. So we will now readjust our pointers, and then we'll calculate until we'll get the value. So 67 is greater, so we're concerned with 41 and 58. So we'll get those, and then we'll calculate the midpoint, and then we'll get the midpoint again. The midpoint will just be 1, and that's where our value 41 is. So that's how binary search works basically. So now know that binary search, the array must be sorted. Okay, if it's not sorted, then this cannot work, because we rely on the sorting to determine how to adjust which part of the midpoint is our value, whether it's located on the left or on the right. So your array must be sorted for this to work. Okay, great. So now let's look at the big O analysis of a binary search. Okay, so we can see that the best case scenario, when the element is at the very beginning, right, we only have to do only one operation at the best case, right? So the best case scenario is when the element is at the beginning and it's just a constant time, and then the time complexity is just going to be a constant. Okay, constant, because we're not creating any arrays in memory, we're just using the same array, just iterating over the same array. The worst case scenario is going to be this is actually made a mistake here. This is actually log of n rather, so I made a mistake there. So it's actually log of n. So the worst case scenario is going to be log of n. Because we're going to be dividing this array almost into half during each iteration. So its worst time complexity is just log of n. Its best time is just going to be log of it's going to be constant time. You will get constant time when you have to do only one operation, meaning that the value that you're looking for occurred in the mid at the first initial mid calculation. So great. So now that let's look at its implementation. So I'm going to open up my Visual Studio Code, and I'm still going to create a file here. I'm going to create a file called a binary underscore search dot Python. You're going to first implement it in Python. So I'm going to create a function here. I'm going to call it binary search, and then for this this binary search, what you're simply going to do is that you're going to take in an array. So again, I'm going to call it an array, and then you're going to find a target. The target is the value that you're trying to find. Okay, so we're going to have our left, and our left is just going to be initially is going to be 0, and then our right node is just initially is also going to be the length of the array, right, minus 1. Okay, because of the 0 based indexing. Okay, so now that we have that, I'm going to create a while loop. So while I told you to continue the process of shifting the pointers and the mid value, as long as the left is less or equals to the right. So as long as the left is less or equals to the right, you're going to be doing the process of shifting the mid value. So we're going to calculate the mid, and the mid here is just going to be I'm going to pass in here, I'm going to be left plus right, left plus right, and do an integer division by 2. So that's how you do an integer division in Python. So we're going to do an integer division because we don't want floating point values, because there's no index that has floating point value. That's to cause our program to crash. Okay, so now that we have that, we're going to check if the item, if the element at the specified mid, right, if the element at the mid is equals to our target. If that's the true, then you're simply going to return return the value from the mid. That's all we're going to do. What if is not equals to it? Now means that we need to readjust our nodes. Okay, so we're going to do you can keep here an else if statement. You can go else if you're going to check if the target is less than the element at the mid, right? So it's going to do array at mid. If that's true, we're going to now readjust our right node. So we're going to say right is going to be equals to mid minus 1. Great. And then else you're just going to left. So you're going to say left is going to be mid plus 1. That's all you're going to do. So if the target value is less than the midpoint, meaning that our value, we need to readjust our midpoint, our right node, to become n minus 1, meaning that is on the left side. Okay, else if that's not true, meaning that if the target is greater than our midpoint, meaning that our value is on our right, so we need to move our left pointer to where n is plus 1, the index of the mid plus of the index of mid plus 1. Okay, so I hope you understand that. So now that we have that, if you're done with this process and we don't find it, I'm just going to return a -1. Great. Yeah, that's all we need to do. So now I'm just going to come here, create a list, and I'm just going to pass in some random values here, 2, 4, 6. Okay, just some random values here, and then 70, and then 50, just some random values. And then I'm just going to sort this. So I'm going to go I'm going to say sorted, and I'm going to pass in my list. So I'm going to I've created the list, and I've now sorted the list and reassign it back to the list variable. So I'm just going to print this out. So I'm going to go binary search, and it's going to take in my list, and then the target. Let's say I'm looking for let's say the index of 2. The index of 2, now this should return to us 0, because 2 is the smallest number inside of this array. So even if this array was sorted, we have 2, and then 4, and then 6, and then 8, and then 70, and then 50, and then 50, and then 70. So if this array gets sorted, which is going to be done by this line, right, we'll have 2, 4, 6, 8, 70, 50, and then 70. Okay, so I can even add some values here. Maybe I can say 30. So 30 should come before 50, just like that. So if the array gets sorted, which is going to be done by this line here, we're going to have an array like this. So if it's looking for 2, then that should return to us the index of 0. So I can go ahead and actually run that in terminal, and this is going to return to us at an index of 0, which is just going to be the place where 2 is. You can see we get back 0. So let me change this to be let me try to find the index of 30. So it's going to be 0, 1, 2, 3, and 4. So it should return to us 4. So I'm going to run that. That should return to us 4 right there. So if I type in something that's not within our array, so I'm going to run this, you can see we got back negative, because 300 is obviously not within our array. So great. So that's how we can implement a binary search in Python. So now let's go ahead and actually implement this in C++. So I'm going to go binary search .cpp file, and then I'm going to include the IO stream, because we're going to be doing some input output, and then I'm also going to include one library here that is going to enable us to do some sorting. So I'm going to include beats / this is going to be beats, it's called std c++.h. yeah, that's what I want. So I'm going to use using namespace std. So int main, and then you're simply going to return 0. So great. So now that we have that, let's go ahead and actually write the function to implement the sorting for us. So you're going to have a function that takes in an array and the size of that array, and then we can implement the sorting. So I'm going to come up here. It's going to return to us an int, so I'm going to call it binary sort, binary search, and then it's going to take in an int array, and then it's going to take in an int n, which is the size of that array. So what you're going to do in here, we're going to calculate the left, and then the left, sorry, this is going to be int left, and then this is going to be 0, right, because the left is 0 by default, and then int right, and then the right is going to be n minus 1. Okay, the length of that array minus 1. So great. So now that we have that, we are going to now write a while loop, just like the way we did in Python. So we're going to say while left is less or equals to right, we're going to while left is left or equals to right. What you're simply going to do is you're going to calculate the midpoint. So then int mid, and this is going to be the sum of, sorry, it's going to be the sum of left, this right, left plus right, and then you're going to divide it by 2, and then we can now pass, this is going to be cast into an integer, so the decimal point will automatically be lost. Okay, so now that we have that, we're going to check if the value at the midpoint, so we're going to say arr, which is just our array, the value at the midpoint, if it's equals to our target. So we also need to take in target, that's what I didn't take in here, so I also need to pass in my target. So this is going to be okay, and move that from there. I can really see this is int, this is going to be target. So that's that, and then you're going to check if this equals a target, then you're going to simply going to return, or you can just simply do a C out here if you want, or you can just return it. So let's just return, because we're going to, we say that you're going to be, sorry, returning it, you're going to be returning mid. Great. So now what if is not equals to the left index? So we're going to do else if you're going to pass in a condition here, else if the midpoint is greater than the target. So if the midpoint, if the array midpoint is greater than the target, meaning that we need to now adjust our right pointer. So we're going to say right is going to be equals to the mid minus 1, the mid minus 1. Okay, so that's the case in case we need to adjust our right pointer, because if the midpoint is greater than the target, meaning that the target is on the left side, so we need to move our right pointer towards the left direction. That's why we're going to move it to mid minus 1. Okay, so we're going to have else. Also, the same we're going to do, we're going to say left is equals to mid plus 1. That's all we need to do, and then at the end of the time, if we go through this for loop and we didn't find it, you're just going to return -1 right there. That's all we need to do. So I'm going to come in here and I'm going to create an array, and then this array can have some random values. So it's going to be 20, 40, 50. Let me just make it random, 70, 90, and then 10, something like that. So now I'm going to just sort this array. So I'm going to go sort, and I'm going to pass in my array right there. So great. So now that we're going to pass in our array, so now we also need to pass in array, and then we need to also pass in the array plus n. So n is going to be the size of our array. So let me just calculate it up here. So int n is going to be size of my array divided by the size of the first element inside of that array. Great. So this will return to us the total number of elements inside of our array, and then when we get back, we're simply going to sort this array, and then once you have sorted, we can now call in our function. So it's called we called it binary search. So I'm just going to see out its result. So binary search, and I'm simply going to pass in, I call it binary search, and then I'm going to pass in my array, and then I'm going to pass in n, which is just going to be n, and then I'm going to pass in, let's say I'm looking for 10. Okay, and then we can end that line. So what this is simply going to do is that it's going to calculate find the position of A, the position of the index of 10 after sorting the array. This is going to be the first element inside of the array, so I should expect to get back a 0, and then you're simply going to print it out. Okay, so I'm just going to run this code. So run it out. Let me see. So it doesn't work for some time, so let me just make sure I save it. It always bugs me, so let me just save it and then try to run it again. Okay, so now you can see it got back 0 because that's where the 10 is going to be after sorting the array. So now let's try to find the index of 20. 20 should now be the second element, so I'm going to save this and then try to run this again, and then let's see. So it's taking some time, so it's going to run the code again. So you can see now it's going to return to me 1 because 20 should be the second element. Now let's try to look for 70. 70 should be the third element, I believe. So let's just try to run it and then let's see what it outputs. Okay, so you get back 3. Yeah, that should be the third element inside of the list. So guys, that's how you can implement a binary search in C++. Now the same code applies for Java, so you can just simply copy this and paste it in Java, and it should also work for you. So guys, I'm not going to implement this in Java. I can leave for you as a simple assignment. Just implement it in Java, because Java and C++, basically you can just copy this and paste it in Java and it will just work for you. So guys, thanks for watching this tutorial. If you haven't yet subscribed to my YouTube channel, kindly subscribe to my YouTube channel. If you guys are having any problem implementing a binary search in Java, you can simply Google it, or you can leave a comment in the comment section below. I'll write the code next time, but just take some time and practice it on your own, because that's how you learn. Okay, so thanks for watching. See you in the next tutorial. Keep safe.